Okay. So similar to the chapters in chapters 5 and 6, it's a build up of hypothesis tests and a build up of knowing your parameter and using your sample observations to infer about your parameters. Where's my pen? Okay. So today's lecture is about simple linear regression, chapter 7. What is simple linear regression? Simple linear regression is a model. So it's a model, and by the name, it is the form of that model is a linear model. What it does, it models or it reflects the relationship between two or more random variables. So the basic model that we're going to look at here for the linear model is called a simple linear regression. Okay, but anyway, a linear regression means a model that will estimate the relationship between variables. And what form of relationship would it models? It will model a linear based relationship. Okay. Another name for linear regression, sometimes they call it as regression analysis. So the basic name of this model is a regression model. So there are many regression models. You've got linear regression models, you've got non-linear regression models. But for a basic start, in order to learn about the regression model, we first look at a linear regression model. And for basic entry of knowledge for linear regression model, it's called a simple linear regression model, which you will learn in this chapter, simple linear regression model. Okay, remember, this model is about understanding, reflecting the relationship between two variables, which we assume to be linear in nature. Okay. So let's look at an example. This example is called a car fuel data. This is actually an old data that I haven't updated, but well, we'll see about it later. Anyway, this is about these are the list of cars. I'm not sure whether you've heard of these cars. These are old models of Proton. You've got Savvy, Neo, Gen 2, Impiana. Impiana is actually in UK. So this is a UK data. Impiana is another name for Wira in Malaysia. So they call it Impian. Actually, it's not Impiana. It's Impian. Anyway, so each of these cars, you can see that we have observations relating to these cars. So in particular, we've got three variables: fuel cost per 12,000 miles, fuel type, and CO2 emission. Okay, so each of these observations, you've got all these information. Now, okay, so okay. Now, talking about the variables for these data set, because you've got 1, 2, 3 variables, when you've got more than more than one variable, we call this a multivariable data. So we've got multi kan, 1, 2, 3, 1, 2, 3, you've got multivariable data, atau sometimes they call it multivariate data. So in books, if you see multivariate techniques, that means we're talking about observing data when you have more than one variable. Okay. Now, let's say we want to investigate whether fuel cost of the cars have any influence on the CO2 emission. So in this case, we can name these variables using a specific term. So let's say I'm just going to look at fuel cost and CO2. So fuel costs so the question is, the objective of the investigation is you want to know whether fuel cost has any influence on CO2. So therefore, we can name this fuel cost as an independent variable and the CO2 as a dependent variable. Okay. So it depends on the objective of the question of your investigation. Depends on the objective, then you will be able to identify which one is the independent variable and the dependent variable. Okay, in terms of terms, independent variable and dependent variable. So you already know what independent is, right? Independent, it doesn't rely on anything. But it doesn't, in this case, it doesn't rely on any other variable. Since we're only looking at two, so either one lah, one of them is going to be independent and the other one will be going to be the dependent variable. So conventionally, we write that in terms of a two coordinate axis, we can define that your independent variable to be in the x-axis, so we're going to write x here, and the dependent variable is the y-axis. Okay, so in a two coordinate system, this is x is going to be y, axis x and axis y. Another name for independent variable is called the predictor variable. So independent variable and predictor variable, they refer to the same thing. And the dependent variable are called response variable. Now another name that sometimes they use for predictor variable, predictor, is called explanatory variable. What variable? Okay, explanatory variable. So if you're looking at the relationship between variables, you need to be able to define which is the independent variable, which are the dependent variable. So normally response or dependent variable, there's only one, tapi sometimes they can be two or more. But for linear regression, normally you have one response, well, not really nearly that, but basically you've got one response variable and maybe you have other independent variable. For example, you have response variable of the level of, I know coronavirus, not level of blood cells in a person. That could rely on the BP, on the blood pressure, depend on the temperature. So maybe you have many independent variable, but you have one response or dependent variable. Okay. So let's look at one example. Let's say you want to investigate the purity of oxygen produced in a chemical distillation process. So in this case, which one is the dependent variable? So is hydrocarbon a dependent variable or an independent variable? Can you identify, class? Which one is the hydrocarbon independent variable ke dependent variable? You want to investigate the purity of oxygen produced in a chemical distillation process. So do you think hydrocarbon would be dependent variable or independent variable? Independent for hydrocarbon, yes. So independent for hydrocarbon and purity is dependent. Sebab kita nak tahu apakah what is the purity of oxygen in a chemical distillation process. So basically in this case, I mean, if you're a chemical engineer, perhaps you would know for sure which one is hydrocarbon and purity. But in this case, you can have a good guess on which one is your independent and which one is your dependent variable. Yeah. Okay. So in most cases, because when you're an engineer, you're the one who will design the experiment. So you will know in practice which one is the independent variable and which one is the dependent variable. Now, in an exam setting, sometimes they will tell you which one is the independent or the dependent variable, but sometimes you can know from the equation whether later we will look at later which one is your independent and which one is your dependent, and also sometimes from logic lah. Okay, all right. Okay, so since you already know which one is the independent and dependent variable, are you able, looking at this, referring to this data, are you able to describe the relationship between these two variables? Since kita tahu kan which one is independent, can you describe to me the relationship between this car fuel data, between fuel cost and CO2? If you look at the numbers here, can you roughly tell me the relationship between these variables? It's just a description. Class? Faham ke soalan saya? Do you understand my question? Higher fuel cost, higher CO2. Betul? Ali. Tang. Higher fuel cost, higher CO2. Okay, Ali, higher fuel cost, higher CO2. Directly proportional. Proportional is a bit but proportional in terms of the amount, kita tak sure, tapi is a direct relationship, betul? Kan betul kan? It's not inverse tak? Kalau inverse is terbalik. Kalau higher maksudnya is direct relationship. Higher the cost, higher CO2. Okay. Tapi itulah, I mean like Izamuddin mungkin nampak macam kenapa dia inverse kan, tapi Ali or Tang and Afiq mungkin nampak memang betul tinggi dengan tinggi, right? So somehow, and Adam, you might say tinggi dengan higher and higher, but this is just a small set of data. What if you have lots and lots and lots set of data? How can you make a conclusion like that? Okay, so in that data analysis, as I've mentioned in the first class, when you get a data set and you want to start analyzing, do not jump into any method first. You need to be able to display your data and visualize what your data looks like, so that once you know what your data looks like, you'll be able to identify which method to use. So one way to do this, if you want to really describe the whole data set, is to plot your data. So plotting is a very important thing to do, plotting data. So from here you can see clearly what your data is saying to you. The data says that betul, when you have a higher, as the fuel cost becomes higher, your CO2 becomes high as well. Okay. Similarly, for hydrocarbon and purity, you can see a similar pattern between these two, right? So tinggi apa tu? It looks memang as the x-axis goes high, y-axis becomes high as well. The response becomes high as well, except for the pattern lah. So if you look at fuel cost and CO2, memang it looks as if it's linear, but here you can see it's somewhat linear. Somewhat linear. So when you're describing relationship in general like this, plotting is a good way to go about this. Okay. So this is other examples of what can we describe as a linear relationship. So this one looks linear as well. So ni macam Izamuddin cakap, ini adalah inversely, it has an inverse linear relationship. This one is direct linear relationship. What about this one? Does it look like it has any linear relationship? What about this plot? Does it look like it has a linear relationship? No kan? No. Nampak kat ni? You can see that it looks like apa? Bentuk apa ni? A quadratic, right? It looks like a quadratic. That means it's inversely, it has an inverse relationship up to a point, and then reaching a point, it will go up again. So it doesn't seem to have any linear relationship. What about this one? This one also doesn't seem to have a linear relationship. It looks a bit random, right? Okay, so it doesn't look as if it has a linear relationship. Okay, so the kind of model that we're going to do today, now the name is linear model, so therefore it is more suited to this kind of data. So that's why when you katakan you analyze data, you nampak data you looks like this, that means okay, this looks linear, that means I need to use a linear model. If your data looks like this, it doesn't look linear, why do we need to fit a linear model? Okay, so this pre-processing of way of approach in analyzing your data is really important. Okay, plotting data is a number one key when you want to start trying to model something. Okay, now, so why do we need a model? Because when we have a model, instead of just describing, oh, it looks linear, it doesn't look linear, we will definitely reflect our data through a function, through a mathematical function. Why? Because when you have a function, let's say this your function is here. Mak sayang, jap cup. Mak katakan function you macam ni, draw, drag, okay lah. Katakan this is your function, a linear function. So if let's say you have a new data here, let's say you have a new data here, not here lah. Here, katakan data you here. That means if we extend this model, we can see what it look like and then we can predict the value either X or Y. So prediction or forecasting when you have a model is going to be very useful. Okay, so a model can be useful to reflect what your observation is. It is useful if you would like to forecast new data or you forecast new data or some historical data that you want to predict. Not predict, normally it's on new data, new observations. Okay. So that's why now when for in the corona period you can see that KKM is looking at models, right? So those models are useful so we can predict what would happen in the future, okay, based on that model. But again, that model has to be a good model, otherwise it's going to be a biased observation or biased prediction. Okay, so one model that you can use for this kind of data is called a linear model. A regression model. A regression model where you have a response y is equals to some function of an independent variable x. So that means any change in x would be reflected in your y. Okay, it's a regression function. And the regression function that we're going to look today is called a simple linear regression function or simple linear regression model. Okay, so what does it mean by simple linear regression model? So it follows the form of this, a regression function, y equals to some form of some function of x. You can x here, some function of x, and it has one response and one variable and one predictor variable or one independent variable. One independent, one dependent variable plus an error. So what this error means, okay. Error ni sekarang saya explain apa this error is epsilon means. Okay, so this is the general model for a simple linear regression model. Okay, now a simple linear regression model is a straight line relationship model between one response or dependent variable and one predictor or independent variable or sometimes they call it explanatory variable. Okay, so this is just like a persamaan garis lurus. Yang dulu you belajar y equals to apa? Mx plus c. Mx plus c kan? So persamaan garis lurus that you learned before in one period of your life is the technical term for that is called a simple linear regression model. Okay. So it consists of an intercept. So C is your intercept and beta 1 is your slope, M. Okay, ataupun B1. Or sometimes you buat Y equals to alpha plus beta X. Okay, so it means the same thing. So you've got a regression in the regression model of a simple linear regression model. You have two regression coefficients, the intercept and slope. Sometimes we don't have an intercept. It's just the slope. So sometimes this regression model comes in the form of y equals to beta x plus error. Sometimes it has that function as well, because this one is sometimes it's going to be 0 plus. So you can have an intercept or without intercept. Okay. So when you learn about persamaan garis lurus last time, remember what you did? You take two observation anywhere and then you find dia punya ni kan, dia punya gradient kan. Tengok berapa distance here and then you bagi kan. So M equals to Y over X kan, ingat tak? Yang tu kan. And then lepas tu, what you did was, you akan, well, looking, your eye would be here, and you can nampak, ini ke, ini ke, ini ke. So, you're not sure. So, because it's just a trial and error. Okay. So, which function that model is, so why do we want to draw this line? Because this model, because the objective of this model is you want to fit the data, all your observation in your data well, i.e. you want it to cover the observations here so that this model can explain your data well. So instead of doing this trial and error approach, what you can do is you fit a regression model. How? Through the method of least squares. So the name of this method of least squares. So basically, what it does is you want to optimize. Optimize what? Oh, I'm going to explain now. Now, when you have this model means that all the observation here, we assume that semua observation kita can be explained. So yi, our response variable, can be explained by this model. Okay, some constant of an intercept plus the slope times our independent variable. So this would have some values. So we say that this line is representing all our observations plus error. So because we have different observations, so therefore this error is very important. Okay. So apa yang kita buat sebenarnya adalah ini. Okay. So apa kita buat sebenarnya adalah, okay, let's say you ada y-x. Okay, this is your observation. Okay, so kita nak line kan? We want a line. Let's say a line goes here. Okay, our objective of this line is so that each distance between observation and our, so this is our predicted line or predicted model or our model. Each distance between observation and our line is the distance kan? So we call this error 1. E1 ataupun not E1 lah, error E epsilon 1. Okay. Another distance, it is epsilon 2. So this refers to the residual or distance or error between observation and our model here. Okay. Up to, so let's go to the En. So each observation has its residual. So this one is called our residual or error. Okay. So yi equals to apa, beta naught plus beta 1 x plus I kan. So this I, so all each observation, so I goes from, katakan ada n, so katakan you ada n observations, so you've got I equals to 1 up to n. So maksudnya each observation has got an error. Okay. So our objective is to find a line which we want a line. So we want a line in which the sum of all our observations has from I to n would be as small as possible, kan? It's an error kan? So kalau benda tu rapat, that means it best fit the line. Dia ngam-ngam, masuk baju dia ngam-ngam. That means kalau ini you dapat all the, ini mungkin dekat kalau pakai baju, if you're fitting into a dress or a shirt, here maybe you have a long sleeve, so that will be error. The distance between your armpit and the sleeve. I'm going all crazy with the. Never mind, tak yalah contoh tu. Anyway, I hope you understand. Basically, you want the line best fit means that you want all the errors here to be as small as possible. In order to minimize this function, so you want to optimize. You optimize using this least squares method. I'm not going to show you how to do this method, so because that's beyond the scope of this study. I think there is dia punya cara dekat dalam you punya textbook rasanya, or you can look at any other textbook and look at the method of least squares. But the objective is to get this value. You want to get this value. All right. So once you have this value, that means you have a fitted model. Okay. So if you have a fitted model or a fitted line. Okay. Okay. So basically, from this least squares method, you will get this value beta naught and beta 1. Okay. Right. One simple way to obtain your fitted coefficient for your coefficient for regression coefficient for your fitted model is using your calculator. Okay, this is 570MS. You can try on your own. So basically, what you do is you want to input your data, your x and your y, and then you will, once you've input your data one by one, your pair of data x and y, and you will get your values. So for example, for this kind of data, you need to masukkan dalam you punya dalam you punya, you need to input in your calculator each observation one by one. So this one is this one, masukkan ni, and then with some buttons in your calculator, you should be able to get your values of intercept and slope. So once you input your data, dapat ni. So what is your fitted model? This is your fitted model. Okay, so this is your intercept and this is your slope, coefficient slope. So this is the fitted model. Fitted model means you nak tahu apa coefficient, the value of the coefficient set in a linear setting. Okay. So please note, a fitted model is not beta naught, the value of here. This is not a fitted model. The fitted model is this one. This is a fitted model. This is the regression coefficient, the estimated regression coefficient. So this is the estimated regression coefficient. Okay. But the fitted model is when you put the regression coefficient inside your model. Okay. Okay. Kalau guna, if you want to calculate manually, there's a whole lot of equation that you have to follow through. Okay. But please use this because the marks tak berbaloi untuk you nak kira panjang-panjang. Okay. I will show you an example of a question on the exam, in the exam. Of that, kejap presenting window. Okay. This is semester 1, 1920. Can you see the PDF file? Okay, good. Now, if you look at the PDF of PDF file pula. Mana ni? Mana final tadi? Oh shoot. Ni. Okay. So, okay. It says an experiment was held to investigate the relationship between the diameter of a nail and its ultimate withdrawal strength. Okay. Here it doesn't tell you which one is y and x. So which one is y, which one is x? Which is the independent variable? Which is the dependent variable? So the question is asking, find the estimated equation of the linear regression line. So in this case, which one is y, which one is x? Which is your independent variable? Which one is your dependent variable, class? Diameter is your x, strength is your y. Diameter is your x, is your y. Diameter is your strength. So diameter is the independent variable kan? Betul. So strength is the dependent variable. Betul? Betul. So dekat sini, in this question, it doesn't tell you, but you use your logic to know which one is the independent and the method. So basically, the strength would be the output of the experiment. So therefore, diameter would dictate whether what strength would be, what response would strength gives. Okay, so okay, betul. Now, so in this question, tengok dia punya markah is just 2. Tak berbaloi nak buat all the kira-kira yang panjang tu kan. So it's just 2 marks. So here you need to use your calculator. And then your answer should be in the form of this one. So from your calculator, you masukkan data ni, and then you find what is your intercept and what is your apa ni, what do you call that? What is your intercept and what is your slope? Okay, your regression coefficients, and then your answer should be in the form of y equals to something plus something x. Okay, so sometimes the question will ask estimated fitted line, estimated fitted model. Okay, right. So basically itulah. Ada lagi tak contoh? Contoh lain. Here it gives you this. Dia bagi. So ini finals 12, 13. Here it gives you x and y. So you don't have to screw your. You don't have to think too much on what is x and what is y. Find the estimated regression line. Ni sama jugalah. Okay. Ada lagi tak? Tak ada finals 09. Oh, finals 09. Oh, ni aerosol content. Oh, aerosol. Ni finals 1920. Dia bagi finance 2020 ni dia bagi dua. Satu dia bagi output ni. So we will have a look at this later in the second part of simple linear regression. Dia bagi output of regression in Excel, and then for part B, they ask you to calculate. Okay. Tengok so jawapannya banyak kan. So kalau you nak score on these last chapters of questions. So here again the question is asking a similar thing but in addressed in a different ayat. Best fitted simple regression of visibility on final aerosol. Okay. So regression of visibility on final aerosol. So regression of visibility ni pun another ayat dia kat visibility regression of visibility. So regression of the Y. So the response on X. Yeah. Okay. Okay. So tukar balik ke slide. Faham ya semua? Slide. Ni ke? Share. Okay. So that's one part of simple regression. So as I think I've outlined your e-learning, ada beberapa part dalam simple regression. So one part is this, which is to know how to fit a line. Okay. So when you have this model here, so this is what you are in your on to you don't see so the is one no no Present now. Share. Can you hear me, see my slide? Okay. Oh boy. Tadi, where was I? Mana? This one dah ke? Hypothesis test? This one? Beta equals 0, beta not equals to 0? Shall I repeat balik hypothesis test? Hello? Please repeat. Repeat hypothesis test je. I'll repeat hypothesis test. Okay. Right. Mana? No slide. Alamak. Ni ada. I can see slide. Oh boy. In mine, I can see that I am presenting slide. You guys tak nampak slide eh? I can see slide. Tak nampak? Alamak. We can only see you. Oh my god. Okay, kejap. Stop presenting. I'll stop presenting and I'll try do it again. I can see the regression line. Okay, some of you can see, some you can't. Apa hal eh? Sabar doktor. Aduh. Okay, sekarang nampak tak slide? Hmm. Thank you, Naim, for calming me down. Can you see a slide that says hypothesis testing?
No.
Oh, no. Oh, God. All right. Tak juga. Saya keluar balik. Dah 52 dah. Okey lah. Can you see me and see my slides? Sekejap eh. What about now? We've got 2 minutes left. Can you see my slides now? Okay. Alright. Sikit lagi. Boleh tak sikit lagi? Do you guys ada kelas tak lepas ni? Do you have a class after this? Yes class or no class? Can I? Okay, boleh eh? Kejap ya, kejap. Okay, anyway, macam gini. Kan tadi, alright, we're gonna start now. We're gonna, start recording back. Oh, shoot. Record meeting. Oh, boy. Okay, you guys, if you can't hear me, can you use your phone and tell me so that if anything happens, so I can stop myself, okay? Use your mic and then, nope, masih nope. Syam, you can't see my slide? Okay, can. Okay. Alright. Okay, so sekarang macam ni. Kan tadi kan kita dah ada regression model kan? So regression model ni is y equals to beta naught plus beta 1 x. So remember the concept that a parameter, so basically this is your parameter. So beta naught as beta 1 is your parameter. So the one that we fitted just now is an estimate of that parameter. Okay. Just now what we did was you estimate your parameter. So this is an estimated parameter. These are actually parameters because in your model, we have parameters. So the values that you found that you obtained just now, these are an estimate of the regression coefficient. I can put parameters here lah. I don't really need to do that, but basically these are parameters. Beta naught and beta 1 are your parameters for this model, for this regression model. So when you have a parameter, that means you can test those parameters. Okay, so what is the objective of testing the parameters? So in this fitted regression model, if we test on beta naught, that means we're testing on the intercept, which is not really interesting. The interesting bit is when you want to test on beta 1 or your slope. Why? Because this will tell you whether your model is linear or not. Okay. So when you do a hypothesis test, just like any other hypothesis test that you have done before, is these 4 steps. Okay, 4 steps of defining your hypothesis, testing your calculate your test statistics, get a rejection rule, and a conclusion. Okay, may I remind you that in hypothesis for this upcoming test, make sure when you are asked to carry out a hypothesis test, please follow this procedure. Okay, if let's say lah, you do not write your H naught at H1, tiba-tiba je you terus reject H naught, I will not give you any marks here, although technically it is true. Well, no, not technically. I mean, if I just look at the schema, betul lah tu. Tapi when you don't write your H naught, I will not know what do you mean by that H naught. It can be anything here. So therefore, if you don't write your H not H1, you might end up with just getting marks for your test statistics and nothing else here. Okay, so make sure at each step you follow through, okay, so that you will gain you will gain the appropriate marks. Okay. Now for this hypothesis test on simple linear regression, particularly on beta 1. So in this case, I'm going to use this form of model, beta naught plus beta 1x. If I write y equals to alpha plus beta x, that means here I want beta. So beta here would represent the slope of this model. So I can do beta equals or not equals to 0 or some other form. I can even write equals to some value of some value. For example, beta is k or beta is 5. Okay, it either equals or not equals to. This means that I'm testing on the linearity of the model. My test statistics can be calculated using a t-test with this in this form, where this is an estimate from your sample. This should be from your H naught. Remember, when you calculate your test statistics, you always assume H naught is true. So this is where you get your H naught value. You use your H naught value, and then the standard error is the variance of your beta, which is given by this formula. Now, all these are available on your statistics table. Okay, and up again. And your decision rule, because this is not equals to, here you use the conventional way, or when you want to test your parameters, not equals to H1, that means this is a two-sided test. So this is alpha over 2, alpha over 2. And your critical point is given by this one, alpha over 2, n minus 2. So all these are available on your statistics table on page, let me see, what's on page, where? Page. This. Oh, ni. On page 4. Page 4. So see page 4. Page 4, statistics table. Page 4 statistics table, it gives you all the what do you call that, all the formulas that you require for this hypothesis test. And then conclusion. Okay, that's the first example of a hypothesis test. Now give another example. If you have less than some value, so this refers to a testing on the negative slope or negative relationship. Okay, the test samoja, t-test, but then your decision rule is going to be on the left tail test, left tail minus t alpha, alpha and minus 2. Okay, and if it's greater than, this is test of positive slope or positive relationship. So it's the same thing for your test statistics. Rejection rule is on the right hand side, alpha, t alpha and minus 2, and the conclusion. Okay, are we clear? Faham ke? May I have some response please? Okay, senang kan? So konsep je masih sama. Right. Now, so the hypothesis test that I've showed just now is when you do a t-test. Do you remember that when you do, so another approach, selain daripada t-test yang gunakan untuk hypothesis test adalah using an ANOVA approach. So hypothesis test on ANOVA approach. So basically, for simple linear regression, dia punya hypothesis test tu ada dua jenis. You can do guna t-test atau guna ANOVA. ANOVA approach. Ada two approach. Hypothesis test. Okay, hypothesis test for beta, for slope. Okay. You can do dua cara. Satu t-test is ANOVA. So sekarang kita tengok ANOVA punya cara pula. Okay. Remember when we did ANOVA, the punya idea of ANOVA is you want to compare whether ada beza tak dengan mean atau do you have any difference between the population based on variance. Based on variance. How do we do this? What we do is kita akan tengok the variability of your data from two perspectives. Satu through the effect of the treatment and satu is within treatment. So between group and within group. Ini kalau previous lesson on tests of more than two means. Kan? More than two means or mu. More than two population mean. So you gunakan ANOVA. Okay? Dia punya konsep dia macam itu. You akan pecahkan data tu. What you did was you partition your data. So you partition your observations through these two things. So the variability. So this refers to the variability. The variability. Sum of squares refers to the variability. Okay, so all the variability can be divided into these two parts. Okay, so untuk simple linear regression, for simple linear regression, we akan pecahkan. We will decompose your total variability as well, but based on your regression and your error or your residuals. Okay, which can be translated to a test statistics of F test. Tadi P test kan, ni F test. F test of this mean squares of regression divided by mean squares of error. So when you do ANOVA, you need to build this ANOVA table. So nampak tak beza dia? Here, your source of variation now is now the regression and the error and total. And the formula is given by this. Again, the formula is also available in your statistics table. The degrees of freedom untuk simple linear regression is always 1. For simple linear regression, yeah? For simple linear regression, is always 1. Always 1. Okay? And error here is always n minus 2. And this is n minus 1. So this is fixed. Okay? Right. Sorry, fixed. Betul lah, fixed lah. Sebab ni n ni refers to n number of observation. Kalau ada 10, maknanya 8 lah. So, therefore, dia punya formula masih fixed. Tapi konsep masih sama lah. Once you get one ni, so this is the difference between these two. So, this should be your F test statistics. So, whether you do ANOVA or t-test, your conclusion would be similar. So, it's equivalent, yeah? So, the method of conclusion, so for your ANOVA test, you need sama juga, you kena buat. So, again, for ANOVA test, you need to do sama juga, you need to do H0, H1. You need to do t-test, ANOVA table and F test. You need to put your rejection rule and then conclusion. So here your rejection rule is your F test would be, so reject H0 if your F test is greater than F, this is alpha je kan, alpha, F alpha, dulu macam ni, F alpha, 1 ANOVA. Tak ingat lah. Dulu kita ambil apa? Ini dengan ni Tak ingat. 1 and n minus 2. Saya rasa ni 1 n minus 2. Nanti saya check balik. So, you rejection if F test is greater than this one and that one. And then conclusion. Okay. Right. So, that's hypothesis test. So again, when you have a parameter, you can also calculate its confidence interval. Okay. Apa ni? Textbook 154. Okay. Textbook 154. What do I mean by confidence interval? So why do we need to find a confidence interval for the beta? Okay. Because we want to know the possible value, want to estimate the possible value that beta can take. Okay. So here macam juga, so recall when you were trying to find the berapa percent confidence interval for mu, what you did was you do x bar, you get an estimate, the best point estimate for mu, you get x bar plus minus some marginal error. Okay, so similar to this, if you want to know the confidence interval for the slope, okay, beta, so what you do is you need to have beta hat. So this one is your sample, your sample estimate of your beta plus minus the error, okay, where the formula is given in your statistics table. So you will get a possible value for beta. All right. Do you have any question? So next class, I'm going to talk about some assumptions of the model and how to check for that. Okay. Ada soalan ke? Do you have any questions so far?
No.
No. Okay. So itu saja basically untuk hari ini. Tak ada doktor. Okay, good. So basically, sama juga. So I think tomorrow, do you have any question? Do you have any particular question that you want to discuss? Sebab kalau tak ada, I'm going to give you time to do your revision tomorrow. Besok apa? Besok Khamis. Besok Khamis kan? So do your revision. You can ask me question privately. And so I'll see you next week. So what I'm going to next week is to continue with assumption of the model and diagnostic check. Sebab when you do this hypothesis, remember when you do hypothesis test of parameters for the usual population parameter, you assume that your data has a normal distribution. That you can check goodness of fit test, or you can check using some plots. But for simple linear regression, the punya assumption is slightly different. Okay, so you need to check whether your assumption, the model holds. Barulah you punya all your test and confidence interval that you have done before is valid. Okay, so that is what we can do. Can we do partial question for this chapter next week? For this chapter next week. When do partial question for this chapter next week? Boleh? Can we do partial question? Boleh? Once I have finished this, we can go through the question of partial question. Partial question for next week. Yeah. Okay. So next week. We're going to continue with simple regression on model assumption, diagnostic check, Excel basically, Excel, Microsoft Excel, and its diagnostic check, and using its diagnostic check. Okay, so using its diagnostic check. Okay. Okay. Can you do partial question for this chapter next week? Can you do partial question for this chapter next week? Okay, and then and also okay, I'll do one partial question. But it will help if you you practice on using your calculator. Please practice on the exercise on your textbook. For let me see. You can try this. Nak try sama-sama ke? Tak yalah kot. Hypothesis test. Okay. Sample. Okay. Practice on the exercise on your in your textbook. Please practice on the exercise in your textbook. Buat contoh je. Let me see. No have lah. Okay. Okay. Okay, I'll do ni lah. I'll do ni. Semester 1. Semester 1. 1920. Question on regression. Regression. Please practice. I'll do semester 1. 20 question on regression. You can practice on practice. You can try first. You can try first on part B. On part B. B till the hypothesis test. Hypothesis test question. Okay. Okay, so basically we'll discuss semester 1 1920 question on regression, tapi I'd like you to try first question, and if you can try on the first part. Tadi soalan je, soalan regression je. Let me see. Let me just stop this presentation for a bit. Window. Kejap. Share. Oh, actually you can do all this question actually. Part B. Tapi tak ada jawapan 2013 tu jawapan tak? Did I give you jawapan for 1213? Okay, tak apalah, you can try this one. You can try part B. Okay? I'd like you to try question 7 ke ni? Question 6, part B. You should be able to answer question 1 and 2. Okay? So, please try semester 1, 1920, question 6, B. 1 till 2. You should be able to do this now. You do this using your calculator. Okay? Alright. So tomorrow tidak ada class, okay ke? You can try on. I think you need to practice on your on your test. If you have any question, you can have a session with me ke? Kalau you nak buat session ke, you can book an appointment. Kalau you ada stuck with something. Tapi basically, you'll be tested on confidence interval and for hypothesis testing. I'm more concerned that just follow through whatever I have taught. Berapa soalan? Sebenarnya I've not seen the question yet. I've not seen the question yet, so I can't tell you much actually. Tapi from orang yang buat soalan, from the people who've done the question, they say that it's easy peasy. So there won't be any trick question. There won't be any difficult a question. The only thing that I can tell you is that they say that it's senang. Soalan pun saya tak tahu berapa. but I'll be posting a more detailed guideline on the exam. So basically, I will put up the question paper on e-learning, and that question paper has a password. So we'll start with okay. I will put up the guideline on your WhatsApp group, and then you can ask me more later. Okay. Alright. So itu saja untuk hari ini. Ada soalan lain? Okay, soalan. Sekejap, I'm getting your attendance sheet.